we now get to learn more new fun things to do with rational expressions. So in this section, as you can see, it's not a mystery what we're going to do. We're going to learn how to multiply and divide rational expressions. So it should be interesting. But I think like I mentioned in the previous section, if you're ever stuck with rational expressions and you don't know how to do anything like reduce or multiply or divide or add and subtract like we'll learn in the upcoming section, if you ever get stuck, just think about, okay, how would this work if I had two regular fractions, you know, like 2/3 and 5/7 or something. And it's probably going to be really similar with the rational expressions. Okay, so let's read what it says here. To multiply two rational expressions, as with regular fractions, we multiply across. You're going to, in other words, multiply numerators together, you know, numerator times numerator, and then multiply denominators together, denominator times denominator. However, as with fractions, this is important, it is easiest to reduce before multiplying. So what we're going to do is we're going to factor each numerator and denominator, kind of like in the last section when we wanted to reduce fractions, or reduce rational expressions. We factored everything and then canceled any like factors. It's just now we have two rational expressions sitting next to each other multiplying. We're going to factor as much as we can, reduce as much as we can, and then, and then try to multiply across whatever's left over. Okay, so let's see, let's just try this first one because it's pretty nice. It's not too crazy. So this first example up here in the top left, you have 18 over 8 to the 5th, 2a squared over 3a, and you're supposed to be multiplying those guys. But it'll be a lot easier, especially in the more complicated problems, to first reduce and then multiply. So one thing I want to mention is that, as you remember probably with regular fractions, you can reduce vertically, like within one fraction if you can reduce, then you can reduce them. Like for example, the first thing I notice is this a down here in the second fraction can cancel with one of the a's here on the top. So the a on the bottom is gone, the a on the top kind of will reduce to just a regular a instead of an a squared. So you can reduce that way vertically within each fraction, or you can reduce diagonally, like one numerator with the other denominator like that, or this numerator with that denominator. So just keep in mind that it always has to be a numerator and a denominator. The only thing you can't do is reduce across. So for example, I couldn't reduce this 18 and the 2. That would not be good. 18 and 2, even though something divides into both, you can't reduce that way. When you're multiplying fractions or rational expressions, you can only reduce vertically within one fraction or diagonally across fractions, numerator and denominator. Alright, enough said. Let's see what we can reduce here. There's probably more. I notice, just focusing on the a's, I canceled the a in the denominator with one of the a's on the top. The remaining a on the top can actually cancel on the diagonal with one of the a's down here, leaving 4 of them. And I think that's all the a's I can cancel, because now those 4 a's are all that's left in this whole problem. And I think there's one more thing we can reduce. This 3 here can reduce with this 18 to make 6. So all that's left now is the 6 on the top times the 2 that's also on the top. 6 times 2 will make 12. And then in the denominator, all we're left with is the a to the 4th, and there's nothing else left. So we'd have 12 over a to the 4th. But you know, this one, if you were thinking, why don't we just multiply across? This one we could have multiplied across to begin with. We could have said, okay, 18 times 2, that's 36a squared. And then on the bottom we have a to the 5th times 3a, that's 3a to the 6th. And then reduce that way, like, okay, 3 can go into 36 12 times. You subtract the a power. So you could have done that, but like I said, I just want to get the hang of reducing before multiplying, because for these more complicated ones coming up, it would not be a good idea to multiply first and then reduce. You definitely want to reduce and then multiply. It's going to make it way easier. Okay, so I'm going to keep that in mind, yeah. So we're going to, on all these problems, we're going to first factor, like we kind of talked about, factor all numerators, all denominators, and then reduce all you can. And then you're going to multiply across whatever's left over. And you have to do it in that order. It won't work if you try to multiply and then factor and then reduce. It's going to be better to factor and then reduce and then multiply. Let's try it with the next one to the right. We have a numerator. It doesn't matter where you start. I always start, I guess because we read from left to right, I always start from on the left. This y squared minus 16, the first numerator, that's a difference of squares. So he's y minus 4, y plus 4. Alright, and then his denominator, that's 4y plus 12. The factoring I can do there is factor a 4 out. So if I factor a 4 out, let's see, 4 times what is 4y, that'd be y. 4 times what is 12, that'd be 3. Okay, so we've got the first fraction factor as much as we can. The rightmost fraction, the numerator y plus 3, you can't factor that. That's as good as it gets. That's a prime factor. It's a two-term polynomial, so all we could do is difference of squares, difference of cubes, sum of cubes, but that doesn't fit into any of those categories. And then kind of the same thing with the denominator. Y minus 4 doesn't fit into any factoring categories. But I do see that it's going to cancel anyway, so it doesn't matter. I see on the diagonal I've got a y minus 4 that cancels with the one I just wrote, and the y plus 3 above it cancels with the one on the diagonal. But that's about it. The y plus 4 in the numerator left over can't cancel with the 4 on the bottom. Remember that this 4 in the numerator is part of the factor y plus 4, so you cannot cancel those 4s. Again, because you think of y plus 4 as one item. It has to be that entire thing canceling or none of it canceling. So that would be our answer, y plus 4 over 4. Just to remind us, we can't cancel the 4s, even though it seems like we can. Just think of, yeah, the 4 is a part of the factor in the numerator. Alright, and yeah, you cannot reduce those. It's not 4 and 4 cancel. You cannot do that. The 4 in the numerator is part of the factor. Okay, let's move on to the next one. You got t plus 2 over t minus 2. Actually, looking at that first fraction, I notice both numerator and denominator cannot be factored. T plus 2 and t minus 2, they both have two terms, so the only hope I would have is if they have a greatest common factor, which they don't, or if they're difference of squares or difference of cubes or sum of cubes, and they're not. There's nothing I can do with them, but if I look at the numerator in the rightmost fraction, t squared minus 5t plus 6, that might be able to be factored. Since it's a trinomial with leading coefficient 1, it would be that easy factoring technique, where all I need to find is what are the numbers that multiply to positive 6, but add up to negative 5. That would be negative 3 and negative 2, or vice versa, negative 2, negative 3. Because those have a product of 6 and a sum of negative 5. And actually the denominator there, t plus 2 to the second power, that's already factored for me. So you know what I can do actually if you want? This kind of makes it easier for me. If I see something to the second power in these problems, I kind of like to write it out because that really means t plus 2 times itself. That way if something cancels, I'll know what's left over, you know? Alright, so keep that in mind. Yeah, something to the second power really means that thing times itself. And let me see, what can I reduce here? Well, t plus 2 cancels with one of those t plus 2s. This t minus 2 cancels with this t minus 2. And then what's left in the numerator is that one factor of t minus 3. In the denominator, it's the t plus 2. And it may be tempting to cancel those t's there, but you cannot cancel those t's. They're each part of their own factor, and it would have to be the entire factor cancels or none of it cancels. Alright, so you can probably see that these examples so far, it does seem kind of similar to the previous section where as long as you're good at factoring, then you'll be fine. There's just more factoring to do in these problems, since you have two rational expressions sitting next to each other, not just one. Alright, let's try this one down here, kind of to the left side. You have y squared minus y over y squared plus 5y plus 4. But then it's times just y plus 4. It doesn't look like a rational expression. But think about, remember if you have a fraction multiplied by a whole number, you're kind of thinking of the y plus 4 as like a whole number because it has no denominator. You can put it over 1 if you want. Anything can be placed over 1 to make it into a fraction. So if you ever come across one of these, keep that in mind. It's just like regular numbers. If you're multiplying a fraction by a whole number, you can always write the whole number over 1, so it's a fraction. And now let me try to factor stuff. Let's see, we have in the first numerator, y squared minus y. At first I thought that might be difference of squares, you know, you see y squared, okay, that's something squared. But actually it's just, all they have is a common factor I'm going to factor out, that's it. They both have a y in common. If I take a y out, y minus 1 is left. And that denominator, y squared plus 5y plus 4, that's a trinomial with a leading coefficient of 1, thankfully, so it'll be the normal kind of easy factoring technique where I need to figure out what multiplies to 4 but adds up to 5. That'll be 4 and 1 or 1 and 4. And in the second rational expression we have a y plus 4 in the numerator. There's nothing I can do with that. That doesn't factor further. That doesn't fit the bill of any factoring technique. And of course 1, that can't be factored. That's as good as it gets. And I noticed there's only one thing that cancels here. It seems like a lot of work just for one little thing. but the y plus 4's cancel, and that's about it. So let me see, in the numerator, what's left over? There's a y and a y minus 1. In the denominator, there's a y plus 1 times 1, or yeah, y plus 1 times 1. But the 1 you don't really need because we know 1 times anything is that thing. So there's our answer, and I cannot cancel. You can't go like this, like y and y cancel, 1 and 1 cancel. No. Y minus 1 and y plus 1 are completely different factors, so they cannot cancel. And pieces of them cannot cancel. Also, this y outside and this y can't cancel because the y in the denominator is attached to the 1. It's kind of part of the package. Yeah, it's a package deal, so don't try to cancel a piece of it. That's really, unfortunately, as good as that one gets. That one wasn't very satisfying, you know. Not a lot canceled there. But at least something canceled. Alright, let's try this next one here. This one looks a lot more complicated. But if you notice this next one to the right here, you've got each of these numerators and each of these denominators, they're trinomials with leading coefficient 1. So actually these all can be factored the same kind of way. It'll be a z and a z, a z and a z. I just have to find the right numbers that multiply to this and add to this, whatever they are. But they're all the same type of factoring, technique that we'll use here. Doesn't really matter which one I start with. I'll just start top left. I want to know what multiplies to negative 3 but adds up to negative 2. Or sorry, positive 2. That would be positive 3, negative 1. Because those multiply to negative 3 and add up to positive 2. Maybe I'll go downstairs there. The denominator, I want what multiplies to negative 5 but adds up to 4. Well, that'd be positive 5, negative 1. Since positive 5 times negative 1 is negative 5, positive 5 plus negative 1 is positive 4. And if I look at the numerator of the next one, I want to see what multiplies to negative 10 but adds up to negative 3. That would be negative 5 and positive 2. Alright, and then the very last guy, we've got, let's see, what multiplies to 6 but adds up to 5. They're both positive, so they have to be both positive numbers, 2 and 3 maybe. 2 times 3 is 6, 2 plus 3 is 5. Alright, this is the most fun part because I get to go crazy canceling. What do I see in common? Well, z minus 1s are in common here. Those are gone. Way across from each other, the z plus 3s are diagonal from each other. Oh, and actually the z plus 2s are canceling here. But what's left over now is z minus 5 and z plus 5. Those are not the same. The minus or the plus changes things. That's all we can do. That's as good as it gets. Alright, and if you happen, I don't know if you happen to be thinking this, but remember at the end of the last section we talked about opposite factors. I think the problem we had was x minus 8 over 8 minus x, and we said, oh look, those are opposite factors, so we can factor a negative 1 out and reduce more. If you happen to have been thinking maybe these are opposite factors, the z minus 5 and the z plus 5, they are not opposite factors because although the 5s do have opposite signs, negative 5 and positive 5, the z's have the same sign, positive and positive. It'd have to be that both terms are opposite signs. Like in this example that we had down here, x was positive on top, x is negative on the bottom. 8 was negative on top, 8 is negative on or positive on the bottom. So I don't know if you happen to be thinking that these are not quite opposite factors, so we couldn't use that yet. Maybe in another problem we'll be able to use that, but if you weren't thinking that, don't worry about it. I mean, that means you were correct. You shouldn't have been thinking about it because they're not quite opposite factors anyway. But if you were thinking it, that's actually good. You're kind of staying on top of things and remembering things you should remember. But alright, let's try this last multiplication problem and then we'll move on to division, which is not too much worse. It's very similar. Let's see, I'm going to look at all these guys. I think all 4 of these, numerators and denominators, they all factor in some way. The numerator of the left fraction, I think, is one of those simple factoring techniques because it's a trinomial with leading coefficient 1. So it'll be a t and a t. And then I ask myself, what multiplies to the 4 but adds up to negative 4? That would be negative 2 and negative 2. And you know, these are the same factor. You could write it as t minus 2 squared. But I kind of like we did in which example up here? One of these guys. Or was it? Oh yeah, this third one. It was t plus 2 squared. I actually rather write it out separately, so when I cancel, I know exactly what's left over. So even though we've kind of been trained to write t minus 2 times t minus 2 as t minus 2 squared, in this instance, because I'm trying to cancel stuff, I probably wouldn't write it like that. I'd rather spread it out to see what cancels and what doesn't. Alright, so we got that numerator. Maybe we'll look at the denominator of that guy. And look at that guy. It has no common factor to factor out. And it's a trinomial with leading coefficient not 1. Uh-oh. That means we have to use that x method, you guys. Oh, man. This is where you might want to break out a piece of scratch paper, or if you're writing kind of small, you'll probably be alright. I'm going to write it down here. It's 2t squared minus 7t plus 6. Okay, so if I make my little x, I have to think about what multiplies to a times c. A is 2 and c is 6. 2 times 6 is 12. What multiplies to that but adds up to the middle guy, negative 7. I think that guy would be a negative 4 and a negative 3, or vice versa. Because negative 4 times negative 3 is 12, and negative 4 plus negative 3 is negative 7. Alright, we found the numbers. Now we rewrite the first term, 2t squared, the same. The last term, 6, the same. But we're going to break up the middle term into two different t's, where their coefficients are the numbers we just found, the negative 4 and the negative 3. So it'll be negative 4t and then negative 3t. There we go. Alright, then we'll factor by grouping and we'll be done with this, factoring this denominator anyway. I'm going to split this down the middle. Think about what factors out of the first two terms. I think it would be a 2t. If I take 2t out, who's left over there? It would be t minus 2. Alright, now what can I factor out of the third and the fourth term? Between negative 3t and 6, I can take a 3 out. But not only a 3, I want to take a negative out, because you want to take the same sign as you saw above it. So if I take negative 3 out, I'll be left with t minus 2, actually. You need the minus 2 because you want them to multiply to a positive 6. Negative 3 times negative 2 is positive 6. Alright, now they have that t minus 2 in common. The leftover stuff is 2t minus 3. There we go. Okay, so that's the denominator there. That's all my scratch work. I'm going to rewrite that up there. T minus 2, 2t minus 3. Okay. Now maybe I'll move on to the numerator of the right fraction. Now notice this guy's going to be very similar. It's a trinomial with leading coefficient not 1, and there's no common factor, so I'm really going to have to do that again. Do the x method again. 2t squared plus 7t minus 15. Oh, sorry, minus 15 this time. I almost put a plus there. Uh-oh. Let me get a minus going so I don't mess it up. Minus 15. Alright, let me see. I think I have a little room up here. I'm going to put a little x up here. So first I have to do a times c. A is 2 and c is negative 15. 2 times negative 15 is negative 30. I want to know what multiplies to that but adds up to the middle term, 7. Alright, multiplies to negative 30 but adds up to 7. 30 can be what? 6 times 5, but there's no way those are going to add up to 7. 15 times 2, that's not going to happen. 10 times 3, there it is. Positive 10, negative 3. Because those multiply to 30. Oops, sorry, but they add up to 7. Okay. So let me rewrite this trinomial here, but I'm going to split that middle term up. I'm keeping the first term the same, the last term the same, but the middle term is going to be something t and something t, where those numbers are the numbers we just found, plus 10, oops, sorry, plus 10 and then minus 3. And then I'll factor by grouping. I'm going to split this down the middle and see what factors out of the first two terms. I think a 2t. And then what's left over after I take the 2t out? T plus 5, I believe. Alright, and from the third and the fourth term, they have a 3 in common, but I definitely want to take a negative 3 out since there was a negative above it. If I take a negative 3 out, negative 3 times t would be negative 3t. Negative 3 times positive 5 would be the negative 15. So that since they have the t plus 5 in common, I'm going to factor that out. What's left over is 2t minus 3. There he is. Alright, so there's our numerator. Let me go back and write that guy. It was t plus 5, 2t minus 3. Okay. How about that denominator? Oh my gosh, please tell me I don't have to do that again. And I think I don't have to, thankfully. Since that's a trinomial with leading coefficient 1, this guy here. I don't need to do the x method, it's just a simple one. It's only if the coefficient of t squared is something other than 1, that's when you'd have to do this. I just have to think about what multiplies to 25 but adds up to negative 10. Actually, that'd be negative 5 and negative 5, right? Negative 5 times negative 5 is 25. Negative 5 plus negative 5 is negative 10. Now this is the best part. That was all the painful part. Now we get to go crazy canceling. I see the 2t minus 3 across the diagonal cancels. T minus 2 cancels. One of them on the top here and the bottom one. But I think that's it. I was really excited to cancel a t minus 5, but... Alright, I guess they can't cancel because the top one is a t plus 5. Alright. What's left over here? On the top there's a t minus 2 left, but also there's a t plus 5 left. And you know, don't feel like you have to multiply that out. You can just leave it. Just leave it factored. And then on the bottom, notice that I have a t minus 5 twice. Now that I'm done and I have no hope of canceling anymore, I think I'm going to write it as that guy squared. I didn't write that, you know, in this numerator, t minus 2, I didn't write it as squared because I was trying to see what cancels. But now that I know I'm done canceling, there's nothing else that cancels, I might as well write it in a nice way because there's nothing really to do with it. Alright, there he is. T minus 2, t plus 5, all over t minus 5 squared. I think that looks good. Okay. We're doing good here. Let's try some division ones. But remember, you know what actually might help us is, I know it seems silly, but I'm going to divide fractions. So how about, like regular fractions? Like if you had 2 ninths divided by, 8 27ths or something? Sure, why not? So how do you do that? If you remember, you leave the first fraction the same, so the 2 ninths, he doesn't move. But the second fraction flips upside down. Now it's a 27 over 8. This guy, you look at the reciprocal of the second one, or the rightmost one, flip it upside down like that, and then now division becomes multiplication. And you notice now that we're multiplying, these problems are going to become just like the previous problems, because we already just finished problems where we were multiplying two rational expressions. So we're going to want to do that with these guys. All three of these, we're going to want to basically multiply the left fraction by the reciprocal, which means, you know, the same fraction but flipped upside down, of the right fraction. So then pretty much once we rewrite it as a multiplication problem like it's describing, then it'll become the problems just like we saw above. So not too big a deal. Okay, we might as well finish this silly little problem I made up. Here 2 can go into 8 4 times, and 9 goes into 27 3 times. So you'd be left with 3/4. That would be your guy there. It's going to be similar. So we'll do the same thing. We're going to flip the right fraction and multiply across. But before we do that, we're going to reduce like we did here. Reduce stuff and then multiply. Okay, let's try that for this very leftmost one. The left fraction is going to stay the same. It's negative 12 plus 4x over 12. And now I'm multiplying by the second fraction upside down, the reciprocal, 6 over 6 minus 2x. Okay, and definitely don't be tempted. This 6 and this 6 cannot cancel. This 12 and this 12 cannot cancel. Remember that, I mean, right now we're kind of thinking of the 6 in the numerator as part of this factor. 6 minus 2x is one package deal. And kind of similarly, this negative 12 plus 4x is a package deal. So don't try to cancel. Remember, you have to factor and then cancel. Make sure. That's always true with these problems. Factor before you cancel. Don't even try to cancel. Yeah, okay. So looking at the numerator of the left fraction, there's not really a lot I can do. I can factor a common factor out. There's a 4 in common. And you know, now that I think about it, why is it negative 12 plus 4x? Why not 4x minus 12? I think I'm going to rewrite it that way. I don't know why they wrote negative 12 plus 4x. They're trying to freak us out. Excuse me. So if I factor the 4x out, or sorry, the 4 out, what's left over? 4 times what is 4x? That'd be x. 4 times what is negative 12? That'd be negative 3. Alright, and that guy's over 12. There's not really much you can do with 12. I'm going to leave him as is for now. Similarly with the second numerator, 6, it's just a number. There's not really any factoring I can do. But with the denominator, 6 minus 2x, they have a common factor of what? And you know what you can do actually on this one? You can think of that, because remember you want to write it in descending order of powers. You know what I might do? Is write that guy as negative 2x plus 6 actually. And then I'll think what to factor out. Okay, negative 2x plus 6, they have a common factor of 2, but the leading term is actually negative, right? The highest power the highest powered term is negative 2x, and he's negative. So I think I'm going to cancel a negative out. I mean, factor a negative out. Negative 2 times x would be negative 2x. Negative 2 times what is positive 6? It'd have to be negative 3. And notice, if I hadn't factored the negative out as well as the 2, these factors wouldn't be the same, x plus 3, x plus 3. Now they're the same, but if I had just factored a 2 out, not a negative, they'd be opposite factors, and I'd have to do the whole factor a negative 1 out like we learned in the last section. So it really wasn't my best interest to factor the highest powered term sign out as well, a positive or a negative, whatever. Now that the x minus 3's are gone, I gotta be careful. These are a bunch of numbers here. What can cancel? Well, this 6 can cancel with this 12 to leave a 2, which is kind of nice. So what's left over? I've just got this 4, this 2, and this negative 2. But you know what? This 2, for example, can go into this 4 twice, but this 2 can cancel with this 2. And there's really nothing left except this negative sign, so you're left with negative 1. Because there's nothing left. And if you wanted to write it kind of more explicitly, after those x minus 3's canceled, you could have written it as the numbers that were left over. There was a 4, there was a 12, just to make it be real careful. There was a 6 here, and there was a negative 2 here. And you could have canceled it when you were there, but you would end up with negative 1 either way. It's kind of up to you, whichever way you want to write it. That was kind of a tricky one. That's kind of the type of problem where I just assume that I did something wrong because how did it get so nice, you know? How did the answer become negative 1? What did I do wrong? That can't be right. But no, we were right. I think we did it right. Alright, the second one looks like a doozy here. But the first thing I want to do before I even factor or try to cancel stuff for sure is try to rewrite the division problem as a multiplication problem. It's w squared minus 14w plus 49. Same, you know, and you want to keep the left fraction the same. 2w squared minus 3w minus 14. But I'm going to multiply by the reciprocal of the second one. So now the second one's upside down. The w squared minus 6w minus 16 is now in the numerator. The 3w squared minus 20w minus 7 is now in the denominator. Alright. I'm going to try to factor these as much as I can. Let me see. The leftmost numerator, that's a trinomial with leading coefficient 1. So I just need to figure out what multiplies to 49 but adds up to negative 14. And those guys would be negative 7, right? Because negative 7 times negative 7 is 49. Negative 7 plus negative 7 is negative 14. And notice that denominator. It's 2w squared minus 3w minus 14. That's a trinomial. I was hoping there was a common factor, but there's not. So all I can really do is I have to do that the x method on the. Maybe I'll go to the bottom of the page and try it over there. Ah, how does that keep moving so much? I'm gonna move this guy downstairs somewhere. What was he again? 2w squared minus 3w minus 14. Ugh. Let me see. I'm gonna make a little x over here. If the other problem doesn't mind me borrowing some space, I have to do a times c. A is 2 and c is negative 14. So let's see, 2 times negative 14, that's negative 28. I need to know what multiplies to that, but adds up to the middle term, negative 3. See, I think that would be negative 7 and positive 4. Or the other way around, you could put positive 4 and then negative 7. But that would work. Negative 7 times positive 4 is negative 28. Negative 7 plus 4 is negative 3. Alright, so we know how this goes. I'm going to rewrite the bottom term. Rewrite the middle term, keeping the first term the same, 2w squared, and the last term the same, minus 14. The middle guy's going to split up into something w, where those somethings are the numbers you just found, negative 7 and positive 4. And then you're going to factor by grouping. So what can I factor out of the first two terms? Well, 2w squared and 7w, all they have in common is a w. If I factor w out, let's see, 2w minus 7 would be left. And then from the third and the fourth term, you have 4w minus 14. A 2 can come out, that's about it. And it's a positive 2 because there was a positive above it. The sign above it was a positive. So if I factor a 2 out, what's left? 2w minus 7. So things in the parentheses are the same. 2w minus 7. The leftovers from the first big term, that's w. And then plus 2 are the leftovers from the second big term. Okay. So we got that guy. Now that's the factorization of the... I already forgot which one that was. So 2w minus 7w plus 2. Oh yeah, that was the denominator here. 2w minus 7 w plus 2. Okay, now let's look at the the numerator of the right fraction. W squared minus 6w minus 16. Thankfully, that's a trinomial with leading coefficient 1. So I don't need to do the x method. I just can go w, okay. What multiplies to negative 16 but adds up to negative 6 would be negative 8, positive 2. Or vice versa. It could be positive 2, negative 8. Now I look at the denominator and say, oh man, I got to do that x method again because it's a trinomial. The leading coefficient is a 3, which is not 1, right? Oh, great. Great. Alright, let me bring him down here. What was he? 3w squared minus 20w minus 7. Here we go. Alright. We know how this goes. I'm going to draw the little x over here. If I need to erase it later, I will, but oh well. If I need to do a times c. A is 3 and c is negative 7. 3 times negative 7 is negative 21. So what multiplies to that guy but adds up to the middle guy, negative 20. Well, that's easy, huh? Or is it? Yeah, negative 21 and positive 2. Or sorry, positive 1. That. Because negative 21 times positive 1 is negative 21, like we need. Negative 21 plus 1 is negative 20. Alright, sometimes those are the ones I have a hard time remembering. I'm like, oh wait, how can you multiply to negative 21 but add up to negative 20? Now it's like the most obvious factorization, 1 times that number, you know? Oh well. Okay, we're going to now rewrite this guy. The first term is exactly the same, 3w squared. The last guy is exactly the same, negative 7w. But the middle guy is going to split up into something w, something w. The somethings are those numbers we just found, negative 21 and then positive 1. Alright, we're getting there. Now we're going to split it down the middle. Say, what did the first two terms have in common? 3w squared minus 21w. I guess a 3w, huh? What happens when you factor a 3w out? It would be w minus 7. Alright, and how about between the third and the fourth term, what can I factor out? 1w and 7. They have nothing in common, but remember, if there's nothing in common, you still have to factor something out, and you can always factor a 1 out. Because 1 divides into anything, so 1's always a common factor. And w minus 7 would be left, so there we are. Those have the factor of w minus 7 in common. What's the leftovers there? 3w from the first term, and plus 1 from the second term there. So there's the factorization. W minus 7, 3w plus 1. Whew! All that work. Okay, w minus 7, 3w plus 1. Oh my gosh. After all that work, I just say, come on, a lot of things better cancel. I think I'm going to punch something. Punch my computer, punch something. Alright, what can cancel here? I see w minus 7. One of the ones from the first numerator cancels with the denominator. Oh my gosh, is that it? No. W plus 2 cancels across. That's really it? Are you serious? Alright, whatever. Well, what's left over on the numerator is the w minus 7 that was in the first numerator, the w minus 8 that was in the second numerator, and then in the denominator we had the 2w minus 7 in the first denominator, 3w plus 1 in the second denominator. And you can just leave it that way. Don't even worry about multiplying that out. It's fine. Ugh. That was a lot of work. It seemed like whenever I do that much work to factor, you know, that was a lot of factoring. I hope more cancels, and I'm kind of disappointed when only a little bit of stuff cancels like that. Oh well. Alright, we got one more, and then I feel like after this one we'll really have the hang of these problems. Alright, I'm going to erase this stuff I have down here, just from the work from the previous one. It's kind of in the way. Alright, looking at this one, I'm going to see, well, first of all, again, it's a division problem, so I better, before I even think about factoring or canceling stuff, I better rewrite the first fraction as it is, beautiful, and then multiply by the reciprocal of the second fraction. The old denominator is now the numerator, and the old numerator is now the denominator. Okay. Now I'm going to see if I can cancel here, or, you know, see if I can factor, sorry. So this numerator, 8p squared minus 27. You know what? I'm sorry. That was actually supposed to be a cube. I'm going to change that on your guys'. Sorry about that. This power on p should be a 3. Okay, sorry. But, so that means looking at that numerator, okay. The 8p to the third and the 27 have nothing in common. So there's no common factor. It only has two terms. That means it has to be difference of squares, difference of cubes, or sum of cubes. Well, it can't be difference of squares because this power is a 3. Plus 8 and 27 are not squares, they're cubes. 8 is 2 cubed, 27 is 3 cubed. So it's not a difference of squares. So it's either a sum of cubes or a difference of cubes. But I can narrow it down because there's a minus sign in between. It's got to be difference of cubes. Sum of cubes only works if you have a plus. So it might be worth rewriting this guy downstairs and trying to work it out. It's 3p cubed minus 27. So this is, like we said, difference of cubes. And remember, difference of cubes, let's see, difference of cubes. It has the formula a cubed minus b cubed. That's what we're given. It should factor into a minus b, and then a squared plus ab plus b squared. So I just have to identify what's a, what's b here, and then fill them in. So a is what can you raise to the third power to get the first term? Well, 2 to the third power is 8, and p to the third power is p to the third power. So there's my a. And then b is what can you raise to the third power and get 27, the second term? It would be 3. So alright, so really all I have to do is take this little formula, replace the a's with 2p, and the b's with 3. Alright, then I'll fill everything in and everything should be fine. Let's see, so a was 2p. Alright, so since there was an a here, I'll put a 2p there. There was also an a here, it'll be 2p there, but squared, don't forget the square. There was an a in the middle, but I'll put a 2p. And then the b, wherever there was a b, I'm going to put a 3. This was a b here, I'll put a 3. This was a b here, I'll put a 3. There's a b squared here, so it'll be 3 squared. Might as well simplify that before I bring it up to the actual problem. It's 2p minus 3, you can't do much with that. But here you're squaring 2 and you're squaring p. 2 squared is 4, p squared is p squared. Plus, okay, now you have 2p times 3, that's 6p. And the last guy, 3 squared is 9. Aha! Alright, let me bring that up and write it up at the top there. It's 2p minus 3, this is going to get to become a really large problem, times 4p squared plus 6p plus 9. Oh my goodness. That's pretty serious right there. Alright, now I look at that denominator. Where is that guy? He is here, 64p cubed minus 1. You know what? It's another difference of cubes. Because 64 is 4 to the third power. P to the third power, of course, is a third power. And 1 is 1 to the third power. Ah, so I'm going to use that same formula, but with this guy now. Ah, I might as well bring it down here. But at least it's another difference of cubes, so I can just kind of copy the same formula. Difference of cubes, okay. So it's same guy. A cubed minus b cubed is same formula, a minus b, a squared plus ab plus b squared. But the problem we were given was, oh, let me write it in a different color. It was 64p to the third minus 1. That's the different one we're looking at now. So on this one, let me see, what's my a there? A is what can you raise to the third power to get the first term? Well, 4 to the third power is 64, and of course p to the third power is p to the third power. B is what you're raising to the third power to get the second term. So you say, what to the third power is 1? Well, 1 itself. Okay, so now wherever all the a's were, I'm going to replace them with 4p. So there's an a here, I'll replace that guy. Here's an a squared, I'll replace that guy. Here's an a, I'll replace that guy. Blah, blah, blah. Alright. So let's see, a was 4p. I'll put a 4p where all the a's were. There's 1, here's 1, here's 1. And then the b was, what was b again? B was 1. Oh, that's pretty good. I don't mind that. I'll put a 1 where all the b's were. 1 here, 1 there, and 1 there. Alright, once I simplify this guy as much as I can, then I think we'll be done with this part. Thankfully, hopefully this will be the last time I have to come down to the bottom of the page and simplify. 2p minus 1, and then here, 4p squared. Well, 4 squared is 16. P squared, of course, is p squared. Plus, 4p times 1 is 4p. And then 1 squared is 1. Because 1 times 1 is 1. Alright, we've got it. So 4p minus 1, 16p squared plus 4p plus 1. Oh my gosh. And write that guy where that denominator was. 4p minus 1, 16p squared plus 4p plus 1. Ah. Terrible. Okay. And let me see, the numerator of the second guy, you know what? I was all worried about factoring this guy. I thought, oh my gosh, 16p squared plus 4p plus 1, that's terrible. You notice though that he appears down here in what we just wrote. So actually, I wouldn't have to factor it because it's going to cancel anyway. But you know what, if I tried to factor it, let me see, let me bring it down and look at it. Yeah, like if I came down here, let's try right here, 16p squared plus 4p plus 1. You think about factoring that guy and you say, alright, there's no common factors there. There's nothing I can factor out. So I'd have to use the box method, or I mean, sorry, the x method. If I do a times c, 16 times 1 is 16. So you say, what multiplies to that but adds up to the middle guy, 4. There are actually no such numbers. There's no numbers that multiply to 16 but add up to 4. Like 16 is 8 times 2, but those don't add up to 4. 16 is 1 times 16, but those don't add up to 4. 16 is 4 times 4, but those don't add up to 4 either. This is prime. But don't worry, even if you tried to factor that guy, it wouldn't work anyway. But don't panic, because he's going to cancel with his friend over here anyways. And then this last denominator, 4p squared minus 9. There are no common factors to factor out, so I can't do that. It has two terms, so it's either difference of squares, difference of cubes, or sum of cubes. Thankfully, those are both something squared. 4p squared is 2p to the second power. So I can write that in the first spots. And then 9 is 3 to the second power, so that can go in the second spots. 3, 3. Whew! Alright, we did more work off to the side or off to the bottom of this page than we've done in all the problems so far combined, it seems like, huh? Alright, now we get to go wild with canceling. We've already gotten excited and canceled these early. 16p squared plus 4p plus 1. What else? Way across from each other, 2p minus 3's cancel. But I think that's it, huh? Those guys are all that cancels. So now what's left over on the top is just that trinomial 4p squared plus 6p plus 9. On the bottom we have a 4p minus 1 left over from the left denominator, and then a 2p plus 3 left over from the right denominator. And there he is. And like I said before, don't worry about multiplying that denominator out. You could just leave it that way. You did enough work as it is, you know? But really just reducing as much as you can, rewriting what's left over once you can't reduce anything. And just the main thing on these problems, don't forget you cannot reduce until you factor. And once you factor, each factor is its own item, and part of it can't be canceled with another factor. Whew, alright. That's good enough for this section. The next section, but actually the next two sections are going to build up to adding and subtracting these guys, which is fairly complicated, but that's why we kind of split it over two sections. It's going to be not so overwhelming when we kind of take it step by step. But thanks for listening. I'll see you in the next section. It should be fun. Don't worry, not too many more sections of this stuff if you're getting tired of it. But alright, I'll talk to you soon. Have a good day.